Всем привет, я начну.
Hi everyone, I'll start. I'm going to tell you today about infrastructure for the big load test. First, let me tell you what it is. By infrastructure, I mean the tools used to deliver a load. And we create a cluster which ensures that this load is delivered. Then we generate cluster, set up metrics, and generate reports, which could later be shown to the management, to the developers. The target is to start all kinds of tests, different sizes of tests, to be able to scale them if needed. And since all these tests are quite big in terms of volume, we would like to be able to manage them manually, and that's why we develop also the manual management code. I will tell you about our experience of implementation. The product is an endless online board with a number of access users, and they could put different stickers, then create some different information, different messages. They can enter it via online platform and check what's here. So on actually they're working via distribution information mode. Some of the users may generate tables, some of them may create drawings, some of them attach documentation. So the users do whatever they want, but every other user can see what another one is doing. You know, as it always the case, we didn't plan it in advance. So first we were solving the tasks to ensure the growth of users, but as soon as we got 12 million users, now we decided it's time, 12,000 users, we decided it's time to introduce the tests. We had one failure when we could not predict that we could actually fall down, which served for us as a motivation to perform tests efficiently. We were ready to invest in testing because reputation and is very important for us. This is a very simple diagram of our service. I show it here to demonstrate that we and you most probably have different server rows which interact with one another, perform different functions, and in order to test everything under load, it seems that it's only easy to write down what has to be tested, what interlinks have to be tested, and to test different functionalities. We could not approach it in such a way because it would take too much time. We needed the results within a couple of months. That is why we decided to create a realistic test case. It will create a kind of a test cluster which will work faster than our production. An example is, let's take a big city such as St. Petersburg, a city which has infrastructure with the system of roads, underground, subway, and for instance, what will happen to the city if not 5 million people live here, but 10 or 15 million? And in order to test how the city will behave, we built the so-called virtual St. Petersburg and put there 10 million or 15 million users. So we simply imitated production and made a big test that imitates the performance of a real-time product. But for us, the purpose was not simply to make an experiment and throw all our developments away. We wanted to store something. To create such a test, we could follow their data, statistical data on how users operate information. Then our task was to invent how we can load parts of the services and compare them against the real metrics to test whether the scenario was a realistic or not one. So first we create the test case based on the user data. So here an example of the board. This is the board and the users create widgets. Then we analyzed which devices our users apply. And then we could compare what widgets on which boards our users create. The second issue is that to ensure that we know information about our user behavior, whether they're really using something on these boards or just opening them, we decided to trace the data from the database, and we detected that certain users really create the content, the rest of them are just using. Third example is that since we were using JavaScript, the logic of the content is split into modules, and we can calculate a number of queries to the module. Thus, we are able to understand which part of the logic is experiencing bigger load. Here you can see the dashboard. It's a web page which reflects the list of boards. Once a registered user logins to our application, he or she uploads this page and can see the requests. As a result, you will see the number of boards, the number of accounts to which a user might have access, then all account users, so there will be a big data. Then the question is, how can we effectively load this dashboard? We can test and we can see how it behaves under the production mode, or we can put heavy load on the server processing this request, and then after analyzing the statistical data of 10,000 users, see how it behaves. But sometimes only one user can create the same load as 10,000 users if such one single user creates 10,000 boards. We try to emulate such approach. So in order to test, we also created background load to be able to compare what happens if there are 10 fake users and how they would behave compared to the 10 real users. But when we are managing the settings, the boards, we're using different ways of testing. And after we created these unrealistic, seemingly unrealistic blocks, we created realistic test scenarios, which would be very much alike to the production mode. It was important to remember that all parts of the scenario are ensured by the relevant data. So dump data is not suitable for such big data case scenarios. Disseminated or multiple data can also be used. In the end, we decided to use, based on the user statistics, use such data in the way our customer does it. It's the behavior of the user when they create an account, when they send a request. And by collecting all this data, we created a database. So that's the outcome. If you would like to test everything at once, try to build up a realistic scenario with the support of the user statistics, and after that set up the real metrics in the servers. And please do not forget that all this data is part of the scenario. Now I'll talk about the cluster for the load delivery. That's what it looks like. In fact, there is nothing super complicated, it's not rocket science, but work in the dashboard happens by a server connection. That's why we have different plugins. In the Gmat we create a scenario. Taurus launches this scenario. Then later we use the stress client, and after all these things are in place, we load the website. There are web servers, API service and bot service generating the requests. So one user enters a dashboard. The dashboard is being uploaded from the database and is sent to the server. If the second user comes to the same dashboard, then he is redirected to the similar server, and all the users can see what is happening in the board in the real-time mode. After that, we test the database. Here, it's marked in the interrupted line. There are certain procedures. As regards the WS plugin, managers have different approaches how they work with the WebSocket, but the logic is the same. They just open up a connection and continue work. And everything that is happening inside of the box could be developed at your own efforts. One can write down any kind of scenario, then you have the startup, then you made comments. In our particular case, we're not able to write down anything special. There are certain tools, but I have not yet encountered any good ones. You see, work of the WebSocket is usually customized. There are certain packages of data, and if you send your customer to apply it, then you have to, with your own tools, understand how much time it will take to process the request, whether the request was processed correctly. And the listeners for this plugin are written by themselves. There is no ready-made solution. Item number 3 here is the mechanism how to activate packages on the client. If at one time a number of packages is uploaded to the server and attested against this scenario, then it will work much smoother. I'll tell now about the peculiarities of the client app. Of course, we would like to install the WebSocket and repeat certain actions initiated by a client. We have to repeat the client's behavior. This could be just the JS code, as it was in our case, because we are using the JavaScript. And while implementing the JS is a kind of very specific thing. It's not just framework, JS framework like Angular or Experts. And if you'd like to use the existing client, most likely it will not work, because you have to rewrite the structure. You know what we did? We took the client, we took out all the solutions too abundant for us, and used the method we just needed. We used client-focused data, and we were using everything that our client could do. However, there are advantages and disadvantages. A minus is that we are not using the client-server methods, and it's not clear what the server methods should look like. And since we have our own client, we need to understand what server it has, and we need to check client and server for compliance of the models. And if a method was delivered from the server, then the client-server system of communication doesn't perform. But these things happen quite seldom. They're happening only if certain processes on the server side or the client side occur. And if we remain only on the level of client-server interaction, then the stress client requires very little support. There are no functional limitations, because we can always reproduce and repeat this client-server methodology. As far as JavaScript is concerned, it can be a bottleneck for any stream. It could be a bottleneck in the test of your final products. And second, While using JavaScript, we won't be able to start many streams from one machine at the same time, most likely. When we were using the AWS machine, we were only able to start up 30 streams. Another question that comes is, where are we going to place the servers? And we need a lot of servers if we have 30 streams for 500 users. One solution would be to create a cloud server, and in this case we won't have to buy servers. We will install the servers within the cloud. And to be honest, I don't know how to make big tests in our own server infrastructure, because today we want to have 100 tests, maybe next day we would have 1,000 tests, so that's why it's very hard to estimate what will happen in the future. And when there is the question what to choose, either buy a server or use the cloud provider or select the cloud load instrumentations. Still there are limitations because that's expensive, it requires investments. But we have different platforms to use, not only Amazon. And in the end, we had to choose between the cloud providers, which test in AWS. We tested in AWS and Amazon because our production environment is also there. And we thought that it would be cheaper to do the test in such a way. If to compare the price, then Amazon has different features which are not also used in the production mode, such as the balancing, stress resistance. And if we want to keep them, we have to pay for them, and we understand that it's okay to pay for them, but sometimes it could be done 17 times cheaper.
Or you can keep it in Hetzner and then write all these balances in the stack. The stack normally has the possibility to replicate the infrastructure completely. So, but at least we managed that. Also, if we talk about the expensive AWS, so if we there will be 50,000 users and 69 instances, then it will be thousands of dollars needed. So now they have sport instances, like just normal providers. These are instances that can be raised for the time of the tests, then killed after the tests, and these are like spot instances which are 5 times cheaper than if we just would buy it. And the risk is that in this region, at this point of time, somebody would like to raise some infrastructure and he won't have free hardware, then he can offer higher price and buy our instances. So we run a test, and then somebody offers higher price, and then they just take it from us. Actually, we've never encountered that, but that might happen. But at the same time, we can save at least 60% or even more. And that's, of course, very good. And how does it work? Well, normally we use out-of-the-box Cluster, Gmeta, and it has several options how you can launch it. You can use the simplest one, so one master can produce several instances of Gmeta, and we can have a lot of instances of this Gmeta actually. So we can also use the FileBit Kibana, which make log files, and then in the interface we look up which parks drop from these dozens of instances. Also in this Gmeta we have managerial plugin to work with Prometheus. So it's open source, and probably it's it's just open source, and it's good because we can update it. It gives the statistics on use of Gmeta, on used flows, so you can look up the intensity of the user coming in and out, and also we can optimize it. And why do we need Taurus? Taurus is a tool which helps to export the report in your own format. And if you use Gmet, you'll probably wanted to launch it with various parameters for different quantity of users with different settings. And so here you can choose the scenario you need. You can configure the scenario, and also you have configures to control Gmeta servers, and they have their own analyzer of online results. And the point is that these results can be collected separately from Gmeta flows, and it doesn't make the scenario heavier. It has good integration with CI, and as the service is growing, soon it will become distributed, and it can be like used with Ledger. And so if we use Gmeta code, it's better to think from the very start about its productivity, because we can test Gmeta, not our product, at the end of the day. Gmeta cluster is a very nice thing that we strongly recommend you to use it. Big cluster can be much cheaper, and be very careful with listeners of Gmeta, because the scenario has to be tested and testing and contain as less risks as possible, not to affect the work in a lot of test servers. As far as the production is concerned, so let's look at the first image. We've seen the web service, working service. The servers which receive API requests, boards, residents. So it's actually a server which generates resources. There are also other services, but also these services they can be auto-scaled in the prod as well. Also, if we have 20,000 users, then during the downtime we have around 6,000 users. So the quantity of servers, so we don't have to keep the full volume, so we can add them as needed. And this mechanism is very efficient for testing. So first we might have 0, and when we start up the server, the servers will be raised, and we'll have as many as needed for the test. Another interesting story is that, as now we are talking about prod testing, we are going a little bit beyond the announcement of the service limits. It might seem that our team can and need to make these load tests, but I think that we come through the load tests to the conclusion that we cannot do that if we don't understand how the prod is structured. And so we have to understand that load tests are primarily infrastructural tests. So to make them in the right way, we have to understand how the infrastructure is made. Otherwise, it's not possible to develop a scenario. Infrastructure as code is one of the approaches which we try to implement. So what does it give to us? So we produce the prod, it has to be scripted, it can be raised at any moment. It's cheap, yeah, but to make it work, we can deploy it in the stack at the prod where we need it, and we don't have to test it at an expensive site in AWS. And as it's script, the environment will be updated, and understanding of the prod in the teams will help not only to make efficiently the scenarios, but it will be possible to understand how the scripts are made, and you don't need to read 5 volumes of the manual to understand that. So, and as far as the quality is concerned, infrastructure is something to be tested, and the scripts themselves, which will be made by the teams to raise some new features, they can be tested as well. And there are various investigation tests or research tests where, for example, if one of the instances is failed at the Amazon, then we can check other services and whether they can be balanced, the service can survive, or whether it's possible to suddenly redirect the queries. And monitoring, which is we need for the tests, it has to be tested as well. Both logs and the monitoring mechanism itself. It's not directly connected with the load test, feedback of the users, but maybe it's connected indirectly. And this is something that happens with the functionality after being placed in the prod. It also needs some testing. And finally, all our infrastructure that's created in the teams, it's scripted and used to configure startup, to kill the instances, modify them, or create. So to launch the test, we have to make configuration to start the cluster which imitates the prod on the to create instances for Geometry servers to launch Geometry on these instances. And working on so many servers, it requires only 6 commands to start it. And monitoring. So I won't talk too much about that because we use this stack for that. This is nothing. There's nothing new here for you. So what we've done, we just took and copied it from the prod, and what we want the prod to work, and we have set up the metrics that we need. And if it's if we have the full one from the very start, then it's okay. If it's not the full one, we can repair it at the prod as well. And correspondingly, this is the way to test and monitor. But how can it help us? So we have so many graphs, and we start a test to get some results, and we don't get these results. We don't know why. Completely unclear why. So we have a lot of graphs, and we can find a graph with a peak, and then look at why this peak was there. We can take a closer look at it. The reports. It has to contain technical characteristics of the stands, the scenario itself, written in a simple, understandable language. The result clear for the team. The graphs reflecting the status of the stand. Graphs reflecting the problem, and also all the results have to be stored in one place, and also the readable results for the managers. And for this we should use our product. This is the link. You can go to the presentation and follow the link and see how it looks. And the first case is testing of the database. What actually we can test under load. So normally we cannot test some heavy queries. We can make some flow testing. But if we start a test and we see load on the test, so you see CPU and is loaded, and also you see in the graph how it affects the user, and we can understand what is the reason. And so I don't know if you worked with this module that deletes unnecessary objects from the memory, but we see that nothing was deleted here. It just sent the data to the disk chaotically, not according to the schedule. But what was next? So you have to set up the database. So in this module, Podgers, it has a setting to tune up the database to make it of necessary size, etc. So, and for that you need. So you do it like in short steps, like you start up the config, launch it, and then check. But in order to accelerate the test properly, it has to take it's quite long. It takes up to 3 hours, but this is not a short iteration already because it's 3 hours. So that's why normally we check what we've recorded in the prog, in the logs, and here we can use the approach used for big tests. We check the dump in the test environment, make big test, then record everything that occurred there, and then launch the same test without using any tools like Geometry or anything. So this is quite realistic scenario, and it helps to record all the logs, but it also provides for some restrictions because our scenario has to be uneven, otherwise database will be not behaving realistically, and also the prompts.
So, and the second example how we are using it, load test, is to monitor the degradation. So what we can do, we can have one test which works on some simple scale and test them both against certain reference values. Once we do the master testing, then we record down the destination for this master test. And then after our developers prepared certain reference values, we can compare their test values against the reference values and see if the test shows any intertesting errors or not. Usually managers are always interested in how service work. For instance, we may say the service is accessible for 50,000 users, but how do we know that the service is working properly without any slowdowns? That's why we decided that while we are doing load tests, we might check something in a manual mode, or we may start up the functionality of functional tests and check 1,000 cases within the same time. That's what we do. We have a master, we start up this master and perform functional tests in parallel with the load tests. Then we take the data for validation, and then we have the report available with the results of the functional tests, and we may see whether reference values are observed or not. So that's why automatic tests find functionalities and functional problems that might happen during the load tests. To sum it up, I'd say that easily set realistic scenario can test something that you have not even envisaged in the behavior of the product. Prod cluster should be supported by scripts and should be loaded by scripts. Realistic test helps to cheaply test databases, and it's set up quite easily. Also, functional testing under load is possible, though unpopular. The reports that have to be formalized and have to be automatically generated are needed, and they have to be formalized, and the format of these reports should be applicable to everyone. This is it from my side for today. I know it's end of the conference, so this is my last presentation, and I'm not running away, and I would be happy if you contact me via email or via my contact reference data here on the slide. So thank you. Thank you for the presentation. Everything is organized very well, in fact. In your example, have you ever had such cases when cloud infrastructure worked with certain problems, and how you roll it out without deployment on the server? Well, we faced certain problems. Of course we did, and we had quite many of these unexpected problems. One of the last example is that when we were testing the load, and the load simply stopped growing. We analyzed many things, and in the end we saw that the number of requests at JIT was declining. And we found out that Amazon blocked us because we were sending requests from two servers in one subnetwork and had the same IP address. It actually looked very much like DOS attack, and in order to solve this problem we created a subnetwork and split them to different IP addresses. So, but this problem was not spot related. No, it was not. There are certain issues with the spots. If you need at once many servers and you may not have them at the same time. So, but now we're using some virtual ones. We have the new generation of servers. Some of them are already getting outdated. But those who are using Amazon are trying to change for the next generation of servers. When it comes to release and how often we publish the server release, this happens a couple of times a day. Now we do it, I guess, three times a week. Our product is a real-time product, so that's why we cannot publish the releases in advance. Usually it takes up to 3 hours to place a release. And this is because there are people who use dashboards in the real time. And we understand that if people log in the dashboard, sometimes they just can be using different services. Of course, they just do not know it. Well, and if we need to transfer our users from one server to another server, we just switch off the server and they will see only a small click on the screen, kind of unnoticeable, and they simply work on the dashboard while we only know that they are working with another server. Thank you very much for the report. My name is Dmitry. I have many questions, but I'll ask the one which is very much worrying. Why did you choose JMeter for your work? Well, but the answer to this interesting question won't be that interesting. The key feature of JMeter is that other tools were not acceptable for me. I had negative experience of working with other tools. Maybe it was my personal experience. I didn't know how to use it, but I didn't like one, and I didn't choose it. As regards my work with JMeter, I was able to perform all kinds of functionalities using it. And if something is missing, I simply did additional development. We can continue comparison further with other instruments and tools, but that's what it is. What about Catlink? You listed certain problems that you faced, but this one tool works with the boxes, with the socket, and can generate reports, but still you're not saying about this. I assume that I will be asked this question. Maybe we will come to this one day, but maybe something will change in the future. And I can tell you, we can easily change to another instrument and change for this Catlink, but still, yes, JMeter is your first choice. I can't say that we're too much linked and we are great fans of JMeter. We're just using it. Thank you. I have one more gift for our participant. Thanks everyone for participation. Good evening.